All right, everybody, welcome to financial lesson 3. We are looking at basic loans using compound interest. So just a quick review. Yesterday, the last lesson, I don't know if it was yesterday, we looked at an annuity is a series of equal payments made at regular time intervals, and there are different forms such as the ones shown below. So we have a regular savings plan where you're putting money into your savings account at regular intervals, paying off a loan or a mortgage with regular payments is a form of loan annuity, and retirement income is often received in the form of an annuity. So when we're using a TVM calculator to solve non-annual compound interest problems, PY represented the number of payments made to the investment or loan. For questions with no payments, make PY the same as the CY value. And for questions with payments, the PY value is equal to the number of payments made in 1 year. When we were using the TVM calculator to solve annuity problems, the PY value is equal to the number of payments made in 1 year. The present value may be 0 or not. It just depends on if there's an initial amount. It just depends on circumstances, essentially. So if PV is a number other than 0, then an initial sum of money was invested or borrowed together with regular periodic payments. So if you were borrowing money from the bank, you would have a present value. If you had a loan that you were paying off, there'd be a present value. But for example, if you were going to start a savings account, your present value would probably start at 0 because you probably don't have any right at the beginning, and then you start making payments, and then then you start gaining money. So let's go on to look at a problem. Here is a loan problem. Consider the following loan problem. Thomas Cruiser borrows $7,500 from a bank to buy a used car. The bank issuing him the loan charges 8.25% interest per year, compounded monthly. If Thomas makes $175 monthly payments at the end of each month for 4 years, how much of the loan does he have left to repay? So let's just go through and highlight our important information. Well, he's borrowing this much. The loan charges 8.25% interest per year, and it's going to be compounded monthly. So those are two different things. That's why I use two different colors. Thomas is going to make $175 monthly payments, and that's going to be for 4 years. And we're looking at how much of the loan does he have left to repay. Why would this type of loan be considered an annuity? Because Thomas is making equal payments at regular time intervals. All right, so let's actually look at one of our TVM boxes here and figure out what's going on. So our N value is 48. So explain why the entry for N is 4 times 12 equals 48. Well, we know that the interest is compounding monthly for 4 years. So 4 years multiplied by 12 times a year, because there's 12 months, is 48. So 12 payments a year for 4 years. What is the present value and why is it positive? Well, the present value is how much he initially borrowed. So PV is going to be 7,500, and it's positive because it's money received, right? Money into pocket, essentially. Like he wants to use it to buy the car, but he has to go to the bank, and the bank puts it in his, like gives it to him so that he can go buy the car. So it's positive. And then our payment, what is the payment value and why is it negative? Well, how much money is he making for each of his payments? Well, he's making payments of $175, and it's negative because it's money out of pocket. He's paying it back to the bank. What does PY equals 12? Why does PY equal 12 and CY equal 12? Well, we are compounding monthly. Compounding our interest monthly. And PY is 12 because we are making 12 payments per year. So if we put that in, what we'd be solving for is our future value, because the question says, if we just go back up here, how much loan does he have left to repay? So just because he's making these payments doesn't mean he's going to have it all paid off in 4 years. So normally you would leave this future value blank on your regular TVM calculator, and you could click it, and it would pop up saying negative $508. So if we were to do that, we would say that Thomas owes $508.53 at the end of 4 years. At the end of 4 years. So adjust the TVM solver so that Thomas pays off the loan. How many months does it take Thomas to pay off the entire loan with the same monthly payments? All right, so what we can do is we're going to go into our calculator here. We're going to go to the advanced version. So my present value is negative 7,500. My payment is negative 175. This is supposed to be a positive. So if we want him to pay off the entire loan, we are going to set future value to 0, if it will let me. This isn't working. I'm going to attach my keyboard. I do this every time, but you think I would learn, but I don't. Okay, here we go. This will be much nicer. Because that's not supposed to be O, that's supposed to be 0. All right, and our annual interest rate is 8.25. We know that. That's an annual interest rate, so we will leave that. We compound monthly. And so now what we're trying to find out is, well, how many months, if he's using the same payment, how many months is it going to take him to pay this off? So you remember initially he was paying for 48 months, but that didn't pay off the entire loan. So if we click here, it comes out to be 50.95. So it's going to take him about 51 months. Let's go back here. So we are going to set our future value to 0 and solve for n is what we did. And n came out to be 50.95, or 51 months. His last month, he'll make a little bit less of a payment. Well, how much did the car really cost Thomas? So what we're going to do is we are going to assume that he made $175 payments for 51 months. I know it's not exactly 51 months, but we're just going to make this a little bit easier. So he makes $175 payments for 51 months. And when we do that, we get $8,925. So he initially borrowed $7,500 for the car, but because he borrowed that chunk and he had to pay interest back to the bank, he ended up paying not $7,500, he ended up paying $8,900. So almost $1,400 in interest. Interest was $1,425, which is kind of the drawback from borrowing lots of money because you end up paying more than you actually borrowed. Okay, I'm going to skip the next one. And we are going to go on to consumer credit. So consumer credit occurs when an item is purchased and payment for it is made at a later date. There are usually interest charges, which result in the consumer paying more for the item than the original purchase price. The amount of interest paid is called the finance charge. So here's an example. Ginger buys a drum set advertised at $2,950. She arranges to pay for it in 24 monthly installments of $170. So this happens a lot, and you will see stores, especially like electronic stores, they'll say like, okay, buy this home theater system for $4,000 or make monthly payments of $180, so that as the consumer, as the person trying to buy that, you can say, well, I don't need to save up $4,000 to get it now. I just need to make these monthly payments. But the problem is you're actually paying interest. So initially, the drum set is worth $2,950, but she's going to pay installments of $170 for 24 months. So if she makes 24 payments of $170, 24 multiplied by 170, type that into our calculator, you see that she ends up paying $4,080 for that drum set. So it's a lot more than the actual drum set, but she didn't have to come up with $3,000 right away. She just had to make small monthly payments. So Ginger wins because she gets her drum set that she wants, and the store wins because they actually end up selling or making more money off the drum set. So we can calculate the finance charge. That's essentially like the interest that she's paid. So she paid $4,080. We're going to subtract the actual price of the drum set. And when we do that, we get $1,130. So that was how much extra she paid so that she could get the drum set and make payments rather than buying it outright. Chad sees the following TV advertisement. So buy a home theater system for option A, $5,000 now. Option B, no payments for 12 months, then 36 payments of $205. Or option C, 12.5% down, plus 48 payments of $130. Chad only has $1,000 available. Which option is less costly? Well, obviously option A doesn't work. If he only has $1,000, we can't use option A. Option A goes away. It's not enough money. So let's say option A. Not enough money. Option B. He's going to make no payments for 12 months. So he doesn't have to pay anything for a year. But then after that, he's going to make 36 monthly payments of $205. So 36 months is 3 years. So for 3 years, he's paying $205 a month. So we are going to say, well, if he makes 36 payments multiplied by $205 per payment, he's going to end up paying $7,380. Just going to put a little B there so we know. Option C. So option B doesn't look awesome because he's paying a lot more, over $2,000 more for that home theater system, but he doesn't have to pay for a whole year, so he might be able to save up a little more money, which is nice. Option C is 12.5% down. So the first thing we want to look at is what's 12.5% of our original purchase price. So the theater system is worth $5,000. So we want 12.5% of 5,000, first of all. That's not 5,000. So in order to do that, we want to multiply 5,000 by our percent as a decimal, 0.125. As a decimal, this is 0.125. So 5,000 multiplied by 0.125 is going to be $625. So that means 12.5% down means you have to pay that right away. That's your down payment. So with option C, you have to pay this right away, which he can do. He's got $1,000. But then he's going to also make 48 payments of $130. So if we type that into our calculator, what do we get? The answer he doesn't show me. And of course, I don't have my calculator handy. There it is. 48 payments at 130 is 6,240. So what we want to do for option C is add our down payment plus our monthly payments. So if we add those together, what is happening? 6,240 plus 625. We are going to come up with $6,865. So that's option C. So you can see that option A just doesn't work. We don't have enough money, or Chad doesn't have enough money. Option B was more expensive than option C. So option C is our winner. Option C is less costly. Cool. Let's move on. We are looking at, whoa, too far. Credit cards. So same idea as the last page a bit. So it says most people have a credit card, which allows them to access consumer credit. In effect, using a credit card to pay for purchases is similar to borrowing money. Although similar to loans and mortgages, there are major differences in using a credit card. If you pay off the balance on the credit card by an agreed date, there's no interest. So it's important. I have a credit card and I try to pay it off every month because then I don't pay any interest. And so I'm just accessing that money for free. If I were to leave money in the account or like charged on my credit card throughout the month, then I'm paying interest on it. And credit card interest rates aren't super friendly. If you choose not to pay for the item by the agreed date, then interest is charged and the item you purchased ends up costing more because of the interest charges. The interest rate on purchases made by credit card is a great deal more than interest rate on small loan or mortgages. Yeah, credit card interest rates are a lot higher than loans or mortgages. Unlike a small loan or mortgage, the consumer must make a minimum payment each month and then has the option of paying off as much as the remainder of the credit card balance is desired. So if you do have a balance on your credit card, on your banking app, it'll say minimum payment due. And that's how much you have to pay at the end of the month before they start getting a little bit grumpy with you. But you can also pay off more than that. You can pay off the whole balance. It's completely up to you. So credit card charges. So these numbers aren't exact. Every credit card varies a bit, but not a ton. So it says well-known Canadian credit card companies are similar in the way that they apply credit charges. And again, here it's really important to note that they vary from credit card company to credit card company. So no interest is charged if the entire balance is paid off by the payment due date. And the payment due date is 21 days after the statement date. So you will get your statement It'll say you owe this much, this is your minimum payment, and you have 21 days or 3 weeks to pay that off. Interest is charged at a rate of 18% per year, which is quite high. It ranges from like 18 to 22. I think mine's 20, so something to be aware of. Interest on balance owing is calculated from the date the transaction was posted until, but not including, the current statement date. To stop interest accumulation, contact the credit card company for your payout balance for that day and make full payment. Basically, pay it all off if you can. The other important piece of information is the minimum monthly payment is 3% of your balance or $10, whichever is greater. So we are going to use the 3%, $10, and the 18% when we do credit card calculations going forward. Hopefully that makes sense. So let's have a look. We've got some credit card questions here. Here is Matt's credit card statement. So you can see we've got the statement date, we've got payment due date, the minimum payment, and the total minimum payment due. And then we have down here, we have all the activity on his account. So he came into this statement with a previous balance of $1,728.44. Then he bought something at Electronics Extraordinaire for $850 something. Then he went to Dairy King and got himself a burger and a Blizzard. And then he got gas for his car. Then he went to Shoppers. Then he made a payment, which is good. And you can see that it actually shows up. They have debits and credits as negative. So that negative right here means that he made the payment of that much. And then he went and got groceries. So it says, the first question is explain the entry 1,728.44 negative. So that's a payment. A payment of 1,728.44 was made. Calculate the new balance. Well, you can see here that his previous balance he paid off with his payment, so we just have to add the rest of them. So what I'm going to do is add up all of these and all of these and the groceries, because that's what's remaining. So if we do that, we are going to get $1,262.57. Explain how the entry of $37.88 was determined. So this is our minimum payment. And hopefully you remember from the last page that minimum payment was 3% of your balance. So our new balance is 1,262.57. We're going to multiply it by 3% as a decimal, 0.03. And if we do that, we get $37.88. The minimum payment is going to be 3% of your balance or $10, whichever one's more, and obviously 3% of that is much more. Why may the date of posting be different from the date of transaction? So if we go back up here, you can see that, for example, the Dairy Queen purchase, the transaction happened on the 24th of November, but it didn't get posted till the 26th of November. And this is pretty common. When I go check my bank balance on my phone or my credit card, I always get this word that shows me my transaction, but then underneath it says pending. And that is just the transactions take some time to process. So when I see pending, I know it's not charged. My actual balance doesn't incorporate that. So you just got to be aware of that. So some transactions take time to process. It's all digital and it all takes a little bit of time. All right, one problem, and then we will stop for the day. Badisha wants to buy a $400 game console with her new credit card. It is the only item she buys on the credit card for that month. What is the payment, the minimum monthly payment on her statement? Well, if she buys $400 game console. Her balance is $400. She owes $400, and we know the minimum payment is going to be 3% of that. So let's say 0.03 multiplied by 400, and we get $12. $12 is more than 10, so we're going to stick with that. Badisha receives her first statement. She pays the amount 5 days after the due date. What will her interest charge be? Okay, this is kind of annoying. We have to use our interest, or our compound interest formula. Amount is equal to P1 plus I to the power of n. So we know that her P value is $400. That's how much she's paying. Her interest rate is 18%, but because they're charging it per day, it's going to be 0.18 divided by 365 days in a year. And then her n value will be for 5 days. So we can plug this in as 400 multiplied by 1 plus 0.18 over 365. So every day she's gaining interest for 5 days. And that's 5 days after the due date. Remember, if you pay by the due date, there's no interest. And when we calculate all of this, we get $400.99. So we know that she initially paid $400, and now she owes $400.99. So we know that her interest is 99 cents. If Badisha makes payments of $15 each month, use TVM Solver to determine how long it would take her to pay off her credit card balance. So we need to solve interest rate as a percent is 18. Present value is 400. She wants to pay it completely off, so future value is 0. We are going to make 12 payments a year because she's making monthly payments. And we are going to use a CY of, well, compounding the interest daily, so 365. And then it says here, because she's making $15 each month, payments each month, at the beginning, we are going to use begin. I'm not 100% sure why the book says use begin. If you ended up using end, I'm not going to mark you wrong for that because it is a little bit, it's a little bit odd. It's a little bit gray and a little bit foggy. So she's making payments of $15. Negative 15. She wants her future value to be 0. She's paying 18% annually. We don't know this, and we're compounding daily. So if we leave it at end, let's see the difference. 34.39. And if we switch it to beginning, what do we get? 33.72. So they're both going to round to 34 months. It doesn't make a huge difference. So it will, let's use a capital. Take Badisha 34 months to pay off. All right, that's it for L3. Thanks for watching. Bring any questions you have to class and we will sort them out. Don't forget to like and subscribe.